Hello everyone. I haven't made a video about my finds at the local flea market for 4 months. But that doesn't mean there aren't any. On the contrary, I've been visiting flea markets often lately, and this video will be a report for the past 3 to 4 months. There are indeed a lot of cool finds, so without wasting any time, let's get started. But before that, let me remind you that links to previous flea market episodes can be found in the description. I've been bringing various devices from flea markets for several years now. I need them for my projects, but that's not the main reason. For example, here's a microcalculator 33 Malawian kwachas gifted by a neighbor for which he deserves respect and admiration. This thing was made in the USSR. It's not a scarce or expensive item, but I was as happy as a child. By nature, I'm a person who treats old things with respect. Most of them are handmade, and most importantly, such things will never be produced again. I just love working with old devices from time to time, taking care of them, blowing off the dust, and putting them back in place until the next time. Understand me correctly, I'm not a hoarder, and I don't collect junk. Every item bought at the flea market is purchased for specific purposes, or purely for nostalgic reasons. And the first device I bought at the flea market is a vivid confirmation of what I just said. Soviet-era current clamp C4501. This gadget can be called a full-fledged multimeter, as it has basic measuring capabilities and, in addition to alternating current, it can measure voltage and even resistance. The device came, likely with its original case and probes, which we will discuss a bit later. What makes this device interesting? Well, first of all, it is completely analog, capable of measuring alternating current up to 500 amperes, and has 5 current measurement ranges, 10, 25, 100, 250, and 500 amperes. The measurement limit is set with a convenient switch. This device lacks a knob to set the needle to 0, but that can be fixed. This old-timer weighs quite a bit. For comparison, here are modern current clamps. Naturally, its heavy weight is due to the amount of iron, a very sturdy casing, and the measuring head. Regarding measurements, well, as for current, I think everything is clear. It measures voltage up to 600 volts, but resistance, unfortunately, only up to 2 kiloohms. The device has an error margin of about 4%. Well, agree, for an analog device of this level, that's not bad. No, well, there are, of course, analog indicators with such a level of accuracy, but that's another story. Inside, the device is excellently preserved. Old school, manually soldered components. And this is the secondary winding of the transformer. Current clamps are essentially the same as a transformer. The role of the primary winding is played by the wire whose current needs to be measured. And naturally, this results in a voltage appearing on the secondary winding, which ultimately goes to the board. There's some kind of calibration trimmer here, multi-turn, by the way, and a bunch of resistors, most of which function as a simple voltage divider to set the measurement limits. That's why I love old devices. Someone manually labeled the winding data of the secondary coil, the indicator, and probably something else. To measure resistances, the device needs a power source, which is inserted, not into the device itself, but into the probe. In my opinion, that's not very convenient. The set includes probes with alligator clips. Simply, a sight to behold. The quality of the alligator clips themselves is excellent. The probes are not inserted in a modern way. This isn't bananas, it's the Soviet Union. Everything is strict here. You need to screw them into the sockets. Well, why not? It's slow, inconvenient, but reliable. The probe will never pop out of the socket. The device is fully functional and, by the way, quite accurate. I didn't buy it for nostalgic reasons, and it's kind of strange to be nostalgic for something you never had. I will use it for work. I paid 600 rubles. Try to guess what this is in 3 tries. No, wrong 3 times. This thing weighs a lot of kilograms, and it's clear that it comes from the Soviet era. It somewhat resembles a welding inverter. The appearance and overall execution are really cool. Agree, it's beautiful. This, guys, is the oscillator block from an industrial plasma cutting machine KIEF4M. These plasma cutters weighed over a ton and had very good specifications. The power consumption is about 75 kilovolt amperes. The maximum current is over 300 amperes. The cutting thickness of high alloy steel is up to 9 centimeters. Well, not a bad toy. I heard or read somewhere that these things were developed for dismantling ballistic missiles. So, I got an entire control panel from this plasma cutter, which weighs about 30 kilograms. There are all sorts of valves, wiring, analog indicators in this massive piece. It provides arc ignition, but if you compare it with modern oscillators, it's like night and day. They say the device is reliable, but I've started it multiple times and noticed that there were several failures and it tripped the circuit breakers. Overall, it's assembled using a thyristor circuit. Inside, there's a huge transformer that's completely encapsulated. It is controlled by a thyristor converter with a control unit based on a KT117 unijunction transistor. There are several matching transformers, a bunch of powerful resistors, and so on. In general, it's a resonant converter with its own nuances. I didn't find the complete schematic, but there are similar ones. On my second channel, I made a separate video dedicated to this device. You can find the link in the description. I only need the case from it, which I want to use for my homemade inverter semi-automatic welder, which is in the development stage. Looking at this beauty, I haven't been able to decide for several months whether to scrap it or not. As an oscillator, I don't need it, but I can't bring myself to take it apart because, firstly, it's rare, and secondly, it seems to be quite in demand. The overall cost of the remote is 1,200 rubles. The oscillator is working, just lower the volume on your device. And this is the shunt that was in the same remote. Big, powerful, and heavy. Now this, I understand, is made to last and without cutting corners. Shunt 75 SSHMM3-500-05 with a drop of 75 millivolts. It is rated for 500 amps with an accuracy class of 0.5. Calibrated, of course, with a quality mark and all that. I would use it in my Ballast for testing welders, but there are already a couple of shunts rated at 100 amps each. The shunt has massive brass terminals and weighs like 10 Chinese ones, or even 20. Ballast resistance. I used to buy these at flea markets before, but not this length. As a rule, they were small pieces. This is a powerful resistor, used in cranes, electric locomotives for dynamic braking, and more, etc. The resistance of my sample is 1.2 ohms. I don't know where it was pilfered from, but it's a cool item, and it only cost 150 rubles. It can be used domestically, for example, to limit the current of welding machines, in various power stands, when you need to load powerful power supplies and welding inverters to determine their real characteristics. And that's probably it. At the moment, I have no use for such a ballast, but I will definitely find a use for it in the future. A pair of electrolytic capacitors rated at 100 volts and 8,200 microfarads from the Czechoslovak company Tesla. Their appearance is, of course, not great, but in terms of parameters, they are quite good, both in terms of capacity and internal resistance. Unfortunately, I lent my internal resistance meter to a friend for a while, and the transistor tester is not very accurate in this regard and most likely shows an inflated internal resistance. Or maybe not. They sold these capacitors by the box. I only bought 2 because I didn't bring measuring instruments and didn't want to buy a pig in a poke. But in the end, they turned out to be working. The next day, I went back to buy the rest because they were selling them for only 50 rubles each. But, unfortunately, someone beat me to it. Considering that the barrels are quite high voltage, they can be used anywhere, in semi-automatic machines and in power supplies for amplifiers as a power filter. Well, in general, they will clearly be put to use soon. A 12-watt DC electric motor DM226 with excitation from permanent magnets. The motor is 27 volts, which suggests that such motors could have been used in aviation, for example. The shaft has about 3,800 revolutions per minute and a torque of almost 0.03 Newton meters. It weighs quite a bit, around 300 grams. It's made, naturally, at a high level. The brush assembly alone is impressive. The brushes can be easily replaced if needed. I didn't take it apart completely. It's all clear anyway. Classic design, magnetic stator, and a rotor with windings. I've bought similar motors before for specific purposes. They are very convenient for use in various small drilling machines. The main feature is that due to its design, dust doesn't get inside the motor, which increases its reliability. Motors of this type can still be bought today, but they cost quite a bit of money. I got it for only 300 rubles. The motor can easily operate in quite harsh temperature conditions from -60 to +70. And by the way, it's fully functional. Another electric motor. This time, it's bigger and heavier. I bought this motor quite a while ago and paid 800 rubles for it, but it's worth it. It was purchased for building a jack, but in the end, the jack was made with a specialized motor with a drive. And this beast took an honorable place on the shelf next to other motors. The motor is an MB42 type, a commutator motor with electromagnetic excitation. The supply voltage is 24 volts, although there are options for 27 volts as well. The nominal power is 175 watts, and the torque is about half a Newton meter. The shaft has a decent 3,500 revolutions per minute, and this thing weighs just under 5 kilograms. The total power mass is grounded to the casing. The motor's rotation direction is right. Apparently, it was used to spin a fan in some special equipment. It has dust and splash protection, and is fully operational. It can easily be used for building lightweight electric transport. However, you should ensure proper cooling. Let's move on. Here are 3 heavy suitcases. Let's take them out, into the light, and look at the contents. The first and second, the smaller ones, are KAT15 and KAT16 autotransformers. They were intended to power ancient cinema equipment. They powered powerful low-voltage projection lamps and power amplifiers. They operated from a single-phase network of 127 and 220 volts. There is nothing special about them, aside from the transformers and the metal casing, which was typical of Soviet non-consumer devices of that period. The nominal power of the KS16 is 710 volt-amperes. The transformer is monstrous, all with copper windings. At the output, it delivers alternating voltage of 110, 30, and 34.5 volts. The device has a 12-position switch that allows you to adjust the voltage, and a voltmeter. It weighs 9.5 kilograms. It's a reliable thing simply because there's nothing to break. But it's also made with care. The second device is similar to the first one. Where can they be used? Well, aside from their primary purpose of powering film projectors, their transformers can easily be used, for example, for a charging or jump-start device. However, the secondary winding will need to be rewound. They can also be used to power various tube constructions and so on. I believe that these things are still in demand today because an iron transformer will always be in style, despite the development of pulse technology. And transformers of such quality are already hard to find. There are people who are passionate about vintage film equipment. Maybe someday, I'll give them to such a person. For now, let them stay with me, better with me than being scrapped for metal. After all, it's history. The KPP-15 is even older, from 1967, also with a switch and an analog voltmeter. Inside, there's a huge power transformer with winding insulation in the spirit of the old school. I found a passport inside on faded paper, with the serial number and specifications of the device. A real signature. Someone, maybe your grandfather or grandmother, once tested it and was responsible for this device. The third suitcase is something else. First of all, it's huge, and secondly, it's entirely made of aluminum. As a device, I don't need it because I have no use for it. I took it because even today they ask for 50 to 70,000 rubles for them, and that's no joke. This is a portable measuring kit of the K50 type, made in 1966. This is a device that, despite its age, is still quite in demand in the industry today. It is designed for measuring current, voltage, active and reactive power in single-phase, three-phase, and four-phase circuits. We have some really beautiful vintage indicator heads, voltmeter, ammeter, and wattmeter. On the sides, there are powerful power terminals, with switches and a phase indicator nearby. You can read about the more precise specifications and full functionality of this device online. I want to show you what's inside it. Here it is. How can you not look at this for hours? We have a bunch of coils on the back of the analog indicators. Honestly, I haven't delved into whether these are inductors or precise resistors from that period. They often did it this way in the past. Perhaps these things form voltage dividers for the indicators to work in different measurement ranges. Look at these power switches and how well they are made, the size of the contacts, and the overall connection area. You can clearly see the contacts with silver pads here. Beautiful and neat assembly. The wires are bundled with plastic ties, and the power wires and connections are made to last a century. The device is, of course, assembled entirely by hand and, judging by everything, with great care. In the center is a toroidal current transformer. There's nothing to criticize in such devices. The assembly is mounted, which was the norm back then, and it gives it a more rugged look. Despite the device gathering dust for decades somewhere, inside it looks as if it was made yesterday. The tinned areas shine like on the first day. Back then, they didn't bother with all sorts of directives and didn't think about using lead-free solder. If it were lead-free, everything would have rotted and fallen off long ago. Unfortunately, I didn't check its operation, but I'm almost sure it's fine. This old timer will outlive us all. I will just keep it. Again, maybe someday I'll give it to someone who appreciates history and craftsmanship. I paid only 2,800 rubles for 3 suitcases. Conclusions. Many will say he bought all sorts of junk and is as happy as a child. Undoubtedly, many things I buy will sit and use for months, even years. But this is not junk. Looters who break things consider them junk. For example, this device could have been dismantled for its aluminum casing and the silver droplets on the switches. But is it worth it? I don't mind when already broken mass-produced equipment, which is impractical to restore and not scarce, is finished off. I understand that everyone needs to make a living. But if someone destroys a working, excellent Soviet oscilloscope or, for example, a voltmeter like the SHCH31 or V7-18 right before your eyes, it hurts. However, a radio destroyer will never understand a radio enthusiast and vice versa. In general, respect old equipment. It will never be produced again. Modern equipment is made by soulless robots, while the old was assembled by people, and it has a soul. That's all from me. Please share this video with your friends if you liked it. All useful links, as always, are in the description. I have to say goodbye. As always, this was Kazyanov K with you. Until we meet again. Goodbye.